Wasn't happy with the technology. My computer kept like crashing, like when I was going through the answer key. So it was like kind of annoying that I was recording and then the screen would just go blank. So, yeah, it was just kind of painful when we're trying to over test scores and whatnot. Okay, so perfect. Let that warm up. I'm gonna hand out your test. I want these back. Don't throw them away. Don't crumble them up. I'm gonna collect them back. Now remember, before I hand these out, you can always retake it. You have every option to retake every test one time. You can always do that. You just have to come in the morning or after school and spend 10 minutes with me to review the problems you missed, and we assign you a time. You have to have it retaken within 1 week. If you fail it, you have to retake it. You have to, you're forced to, okay? That's a school policy. For me, I allow anyone to retake it no matter what. So even if you got an A- and you weren't happy with it, you can retake it anyway. But you always get the better of the 2 test scores. So I know that's the question I always get, better of the 2, so it's a no risk gamble. But it is a new test. It's not the same exact one. I go through Epic new vocab, new problems, so, but it's set up the exact same way. Okay. All right. Sarah. Okay, Autumn, here you go. Oh, that. Hey, way over there. There he is. That's a perfect stick. I don't know how you just hit that, just like so perfect. Right on my wrist. It's so weird.
I need a couple of
Get the one.
Okay. Okay, so have your test out in front of you. We're going to go through the answers. Do not throw them away. Nothing should be on your desk. So we're going to go through the answer key real quick. All right. Okay. Lieutenant, can you hit the lights for me?
Yes, sir.
Okay. All right. So, real quick, have your test out in front of you. Remember, I am recording you guys' class today. All right. So, a line with 2 endpoints, and all the points in between is called a segment. That's a line segment. It has 2 endpoints. Intersection is 2 objects cross and they share points. That's an intersection. The interior points connected by a segment across the edge of the polygon. That's called concave. It's that book definition, concave. The set of all points is called space. Vertex is the common endpoint between 2 rays that form an angle. A polygon is all angles that are congruent, or sorry, equiangular is all polygons that are congruent. Sorry, I didn't know if I said that. Exterior is the points that lie outside of an area of an angle. That's an exterior point. A right angle is the angle that's measured to be exactly 90. That one's also that's always like switched with complementary. A right angle is one angle that measures 90. Complementary is when 2 angles add to make 90. Angle bisector, the one in the middle, is a line ray or segment that cuts an angle in half. That's an angle bisector. The actual object cutting the thing in half. Oops, sorry. I'm going to go too far down before it jumps to the next page. Okay. Collinear is all the points on the same line. Congruence, equal in size, shape, and measure. A line is a figure that goes in both directions without limits. And midpoint is the specific point, notice specific point, that's midpoint, that's in the middle of an object, so it's at its center of a geometric figure. All right, there you go, there's your vocab. The only word we didn't use was obtuse. Because remember, on your test, there's always one word I don't use. On the next chapter test, chapter 2, you'll have 2 words you won't use. The practice guide is a free-for-all, but the test will only have 2 words you won't use. And I build up as we go through each chapter test. Okay, let me zoom out here so we can see the bottom question. All right, now here comes the start of some rough questions. I'm going to make fun of people, that's just what I do because I think it's funny. All right, so I don't have specific names, but I have the answers that they provided me, which I found humorous, and I cried a little bit inside when I saw it. So, all right, name a line that is only on this plane. That would be line M and N. Because what I told you when you started your test is that line L pokes right through the paper. It pokes right through it. So it's not on the plane, and I even said that. It's poking through it, it's not on it. And I bit my tongue because that was the second question. Which line is not on the plane is line L. Now, if you didn't call it line M or line N or line L, you could have called it the 2-letter system. Like for instance, line M could be called YR with the arrows above it, or XR or XY with the arrows above it. But here's the crazy answer I got for this one. For number 2, name a line, instead of naming line M, this is what somebody put. Line X, Y, R, M with big arrows above it. You failed on so many levels. So, number 1, way too many letters. Number 2, this thing should never be in the 2-letter system, because that's the name of the line, it's not one of the points on it. So that one shouldn't be there in the first place. Well, you had too many, so get rid of one of them. Now, the other thing you failed on, you shouldn't put the word line in front of it, you already had the 2 letters with the arrows above it. The only time you use the word line is when you use the cursive letter by itself. So you really failed. I guess the only way you could have went really over the top is put an angle symbol out front. Then you really could have the trifecta. So, but yeah, it was just one of those things that kind of sucked. It made me cringe, but also kind of laugh because you really went for it. But that was the first one. Yeah, full sin. But line L. All right, the third one. Name a line that contains point R. Okay, so R has line L, or you could call it RZ with the arrows. You could have WY, or sorry, YR. That has point R. The weirdest answer I got for this one, name a line that contains point R. This is what somebody put. WY. Doesn't have R on it. Real nice job. Alright, so, real classic. Moving on. So, next one. Name the intersection where M and N cross. M and N cross right there at point Y. I had somebody tell me angle WYR. It's an actual point. It's where they cross. Name another name for line N. That's WY or YW with the little arrows above it. Okay, don't call it line WY, so I wanted the YW with the arrows. Okay? I was pretty lenient. Sometimes I just crossed out the word line and I kind of let whatever you had behind it, unless it was really bad, like some of those examples I said earlier. On a future test, I'm not that kind. I'm pretty straight up and brutal when it comes to a test. So if you thought this was bad, you should see it when we're in the middle of chapter 2 and chapter 3, when I expect you to always get those right and never make a mistake, because you just miss all the points. You don't even get one. So, okay, we good? Moving on. Okay, we're on now the next page. So this is page 2. It's got the one with the fish. Sorry, I can't have this. They're all like crooked. I don't know why. I don't know why that's crooked. All right, my OCD goes off. All right. Anyway, you have to find the measure of how long the fish is. The fish is 5.7 to 5.8. I know it was the weird in between. I had some really clever people say it was 5.75. I even had one cheeky person say 5.72. Whatever. Okay. So if you did the fractions, fine. It's out of 10 now. I had somebody say it was out of 16. There's not 16 hash marks between 1 centimeters. That's only going by tens. Now the weirdest answer I got, and it's not really weird, it's just like, I don't know how they came up with it. The answer I got was 5.14. I don't know how that came about. I know like the tech industry, like 5.14 is like later in like the life cycle of like technology, like when they update software, they say it's 5.13 or 5.11, that's like later on. But to me in math, 5.14 is in between 5.1 and 5.2. It's here. You're ways off. So, I don't know if you meant to write 5.74 and just missed the like hash mark. I just don't know how that came about. I was really impressed with one of the answers though. A couple people put 5 and 8/10, right? But then they simplified it and said 5 and 4/5. That's actually really good. I'm actually impressed with that. All right, moving on to the next one. Number 4. Okay, now the start of the train wreck. Right here. This is the start of it. Later on, when we get to number 9, that's the finish of it.
It starts.
Okay, so here's the start. So when you draw this, you have to draw the segment, put y in the middle. Y is in between x and z. You had to see that. Now, once you have it drawn and you label it, x, y is a 7a, y, z is a 5a, and the whole stick x to z is 6a plus 24. Now, on that picture, which parts are the small pieces? Yeah, 7a and 5a. They're the 2 small pieces of the picture. I don't care that 7a is a bigger number than 6a. The 2 small parts of the pictures are these 2. You have to add them together and set it equal to the whole stick, which is the 6a plus 24. The reason why I bring this up is I had somebody in here that just like randomly picked what are the small parts. It's 5a and 6a. And let's throw everything else to the other side. Like, that's not how you do it. You don't just pick and match and, random things together. You got to actually look at the diagram and see which parts are the small pictures. You add those together, get 12a, I subtract the 6a across, get 6a, you divide by 6, you get 4. Then you have to plug it back in, and this is where some people just forgot to do it. You probably missed a point if you didn't plug it back in. You had to plug it back in here. You had to plug it for yz, because if you didn't read the instructions, you had to find yz. So if you plug the 4 back in, 5 times 4 is 20, that's how I found it. I was really impressed. There was a couple people that actually plugged the 4 in everything and found every stick. Good work. That's going overboard, but you're actually good. That's pretty solid. It's just that.
Everything?
Yeah, they plugged 4 in everything. They found every stick, so 28, 20, and they found the whole thing was 48. That's clever, but I didn't ask for that. That was just kind of going overboard. All right, now the next one. This one is the one I'm talking about where it's a really bad train wreck. All right, so I labeled it. I had the 11d, the 9d minus 2, and then the whole stick is 5d plus 20. Yes, this is the big stick. So you add these 2 together, you say equal to the big stick. Fine. What's 11 plus 9?
20.
Not 18. Somebody put 18 in there.
20.
Okay? It's 20, not 18. Now, the next thing. When you add the 2 across, when you add this 2 to the other side, what's 28 plus 2?
30.
Not 26. So you get 30 on that side. You subtract the 5 across to the side where you had the 20. So when you subtract 5, you get 15, and then you divide by the 15, you get 2. There's some just people that were just randomly adding things too quick, or they're just going too fast. They brought the 2 over, they subtracted it, not added it. Okay, but you had to plug it back into each part, and again, I had people they plugged in everything, that's fine. I just need to see that one stick from Y to Z. It turned out to be 60. Okay, are we good? Moving on. Okay, number 5. There's 2 parts of number 5. You had to find distance. The people who got this one wrong deserve to get it wrong because they didn't read the directions. You had to find the measure of it, the distance of it. I had people finding midpoint. Read the instructions. It doesn't say midpoint. That's the later questions. So, you had this, and I tried to pick the easiest numbers in the world so you didn't actually have to think about it. Going from J to M, from -7 to 0, there's 7 steps. 0 to -7, 7 steps. Going from 0 to 5, that's M to P, 0 to 5, that's 5 steps. You didn't even have to think about it. I went from 0 out to a number. I tried to pick easy ones, so you didn't have to think. Okay, next. Now, if you plug in the formula, it still worked out because you're taking absolute values and negatives. Now, and the formulas are over there, by the way. They're still there. Okay, number 6. The people got this one wrong. Love of God, read the directions. It doesn't say midpoint, it says distance. There's a distance formula up there. So, to find the distance between these, you have to subtract the x's, you have to subtract the y's, so 2 minus a -1. Now, when you subtract these, that's a -7, that's a +3. Now, if you subtract in a different order, that's fine. You've got -3 and a +7, whatever. When you square them, when you type it in a calculator, you have to use parentheses. The people who didn't use parentheses, their calculator told them a wrong answer because you typed it wrong. Because if you type this in your calculator thinks that you are squaring the 7 and then putting a negative sign out front of it. When you should actually be typing this, which will actually give you the right number, which is 49. Positive. Because when you square something, That's -7 times -7, which is positive 49. If that was a -3 times -3 is positive 9. We add these together to get 58. If you forgot the radical, I counted it wrong. You need a radical. You can't just drop it. The only time you drop it is when you actually take the square root of 58, which is 7.6. I could have actually guesstimated that number without even using the math that's involved there.
I need Dylan Piper.
He's in the media center taking a test for me.
Okay.
Okay. All right. So what I mean that I could guess how long it is. If you actually measure the length of one of these bricks, so just the, not diagonally, but just across, and you use that same marking to go, so that's like going this distance, and just keeping that spacing going the whole time, there's actually 7 and a little bit extra. That's 1, 2, 3, 4, 5, 6, 7, and a little bit extra is 7.6. I could have used that gap and just my fingers to estimate what that number is. But I actually wanted the exact number. Now some people didn't actually give me the decimal. They just wrote square root of 58, they moved on. On future tests, I do want the decimal. So you have to use my calculator. Now, on test day, you guys are using my calculator, so it's fine. I'm missing 2 of them. I'm missing 2. After you guys left, there's 2 missing. Now I'm not blaming you guys specifically, but after geometry, because geometry is the only one that had tests yesterday, 2 of my calculators are gone. So, until I get my 2 back, you can't use calculators in here anymore. You have to do everything by hand, including tests and quizzes, until I get 2 calculators back. That's how it works. Even if you have your own, you can't use it anymore.
What?
That's how it works. Because we're a math class, and they can do real. Until I get my calculators back. So, that will guarantee I'll get those things back before the end of the day. So, okay, moving on. There should be 2 left, because I had 1 and an extra one that was not in the container. Okay, so now, we're moving on to number 7. Let's move on to the next page. Number 7. Okay, alright, number 7. Boom, alright, you had to find midpoint. Yes, if you read the directions, it said find midpoint. Now you're finding the midpoint of this one. Okay, midpoint is not just drawing the picture and saying, hey, the middle's here.
Oh, we're only missing 1.
1 in there, and there was 1 extra one that was outside, because I handed out 11.
I did not.
Yeah, so. I handed out 11. I had 11. Okay, now, okay, number 7. On this one, you can't just draw the picture and say that's the middle. You have to give me the actual digits behind it. So, you had to add the 2 x's together, divide by 2. So that's -3 plus 4, which is 1, divide that by 2 is 0.5. Add the y numbers together, 2 and 5. That makes 7, you divide it by 2, you get 3.5. That's the middle. It's over half of 3.5. That's where the middle is. You can't just draw it, you have to actually tell me the numbers. On the next one, you have to add the x's together, that gives you -4. You divide it by 2, that's -2. And then when you add the 5 and -5, you get 0. 5 plus -5 is 0, not 1. So you told me 1. Okay? There's your middle. That's all I wanted. Notice, your middle's a coordinate. Some people are like writing numbers all over the place. It's a coordinate. Keep it clean. Okay, alright, let's go to number 8. Okay, so you had to name a bunch of items that were on this picture. You probably recognize this picture. We've used it a lot in here. You had to name the vertex of angle 4. The vertex of angle 4 is point Q. It's where the dot sits. I had somebody, no joke, told me the vertex of angle 4 is angle 9.
Angle 9.
What?
Was that you?
Again, failing on epic proportions. Next one. Name the sides of angle 3. The sides of angle 3, this is angle 3, are the walls of angle 3. It's the wedge piece that makes angle 3 like a pizza. So that's R to Q, that's one of the walls, and then RP or RT, that's one of the walls. So you can see my answers. They have to be written as rays. If you wrote points, like point P, point R, point Q, you're not doing it right. Walls, sides are rays, they're segments, they're sticks. Okay? Some people are telling me angles. Way to fail again. Name another name for angle 2. Angle 2 is MRN or MRV. You actually see me drawing in mine because I couldn't actually see where angle 2 was until I highlighted it with a pen. Now, the next ones. There are so many different angles that I could put for the linear pair or the vertical angles. I just had to see which ones you gave me. Because I'll just give you a couple examples of what I mean by a linear pair. 2 angles that are side by side that add up to be 180. A linear pair is like 5 and 7. Those are linear pairs. Could have been 5 and TPQ. The two angles side by side that make a straight line. So now you can see like every option. In fact, I could have picked really goofy ones, like angle 4 here, and the angle that's right next to angle 4. As somebody actually tried that. They said angle 4 and angle PQ question mark. Because they didn't know this other point down the road. If you ever do that on my test, you can actually make up your own letters. I allow that on my test. You can actually add in variables yourself so that you can actually finish the angle if you need to. Because some people are like trying to make linear pair, like two angles that are side by side, and they had the right idea. You're always allowed to add letters to a picture if that helps you with one of your answers, because you're displaying to me that you know what you're doing. Now, on the next one, because again, there's a ton. There's so many different linear pairs there because you just pick two straight lines. You can put letters all over the place if you needed to. The next one, two vertical angles that are acute. Two vertical angles that are acute would be like angle 5 and this angle here, which is RPQ. That's a common one that people are putting. Or angle MNV and this angle here, which is RNP. That one. These are vertical, they're straight across. I automatically counted it wrong if you told me angle 2 and something else. Angle 2 doesn't even have an angle across from it. There's nothing down there. So you shouldn't be picking 2. If you did pick angle 2, you better draw the lines and continue what those letters are so that you can actually list off angles. Like angle 2 is vertical to X, R, Y. You can do that, because again, on my test, you can add lines and markers if it helps you like justify your answer. The only reason I didn't tell you that is because you had enough options there, you could have picked any of them. You had a bunch of verticals. You can't pick obtuse though. 6 and 8 are obtuse. All right. Let's move on to 9, the train wreck. Here's where the train derails. People, it was like pulling teeth trying to get people to set up just a simple algebra problem on this one, let alone try to solve it. You don't have to do vertical. I know in the practice test we had a vertical. I was just picking randomly from page 50 that you just had to pick 2 and set up an algebra problem. Well, I just picked these 2. What should this add up to be? 180. It's not 90s. I told you when you started the test, they are not perpendicular. I said that out loud. It's not perpendicular. That means it's not 90s. So you had to add them together to make 180. The reason why I know that is because you made a straight line. And they're the same letters. That's why I'm doing it up and down, not across. So I add them together to make 180, solve for X. That should not be difficult. And then the other side, the Y's, I do the same thing. Add the Y's together and solve there. So add them together, set equal to 180. I had a lot of people like trying to set them equal because they thought they're all 90s. They're not. You can't do that. You can't assume that. In fact, they're not. I think one of them was like 88 and the other one's like 92 something. So, that was number 9. Let me start and stop the camera here. Every like 25, 26 minutes, because that's digital cameras can't go past like 26 minutes. So I always have to start and stop. You guys haven't had any experience with that yet? Okay, so we'll keep going. I just stitch it together later. You don't even notice. All right, number 10 and 11. You had to give me 3 words per picture. So now, 3 words per picture. Number 10, let me zoom. Whoa, that's really big. All right, this picture, I even had to number the walls because I couldn't actually remember where I started. I counted it like 3 times. And I was like, I don't even know where I started, so I had to number it. It's 8 walls, so it's an octagon, not an octagon with an I, not an octogon with an O, it's an A. It's concave, has dents, cavities, and it's irregular. Now, some people are like, no word. It's got the walls marked, it's got angles marked. Not all the angles. 4 of them aren't marked.
That's what I did.
4 of them aren't marked. There should be 8 angles on the inside of that picture, and there is, but only 4 of them are marked. Not all 8, so it is irregular. I know it's a tricky picture.
It should be. Square
Okay, next. So it's irregular. The walls were marked, but not all the angles. Now, let's go to the number 11. Okay, 11 is a pentagon. It's 5. It's 5 sides. It is convex. There's no dents, and it is regular. All the walls are marked and all the angles, so it is regular. Now, the weird numbers, because I always like to make fun of people, the weird answers I was getting here for a pentagon. I had somebody called it a frappagon. Don't know what that is. Somebody called it a trapagonial. I don't even know what that is. There was a hippogon in there once. Don't know what those are. They're not the shapes that I told. But they're just like random words. You do need to know them because the next chapter we're going into no longer just has those words. They have now properties we have to attach to them. So that's what we're going to get today. I'm going to walk around and collect my tents. They're mine. I want them back. Now, if you're going to retake, you don't need to embarrass yourself or say anything right now. You don't even have to do it in the hall. Just come in the morning. You can start the review process, and we'll set a time. But the retakes have to be done within 1 week. If you failed it, like below, 60%, 59%, you are required to take it. And if you're that person that's like, I'm not coming in to retake it, I call your parents and they bring you in and you have to retake it. Then you're really not going to like me. So.
What did you get? What did I get?
You were 1% above retake.
You're lying.
No, he's not.
You get 69%.
I don't know.
Yeah, you'll eventually get to keep them after the retake.
Well, they get 69%.
So when you come to retake it, you get to look at it for a while. But remember, when you retake, it's a brand new test.
Yeah.
This is just so I have something to go off and you can review why you missed so many.
I got,
Okay,
I got 60. No, like
next. Question. It'll be in the grade book
I told
tonight.
you I'd get it.
Alright,
That's every test.
okay, next. Let me get rid of this. Get rid of that. Okay. Oop, got that. Okay, here's what I'd like you to write down. We have 2 slides I'd like to go through before you're out of here. So two slides I'd like to go through right before you have to leave here. I know we're moving into chapter 2. You're like, Ward, that says chapter 1.7. 1.7 I consider the beginning of chapter 2. The reason why is that chapter 1 ended with talking about 2-dimensional shapes, just the names of things. No properties, just names. Well, what we start with chapter 2, we start with those same 2-dimensional shapes. We start with 3-dimensional as well. We're going to mix them together now. We're going to have a bunch of different names. But what we learn in chapter 2, especially this section and on, in chapter 2, is we now start to learn properties about them. So this is the part that can get kind of challenging for people because there's a lot of formulas we have to learn. And so on the next test, there's going to be a ton of different formulas on the board for you. So we need to get them straight in your heads. We are still going to review those words that some people don't know, like not hippagon and frappagon or whatever those were. But I'm talking about like legitimate words that you should know. Okay? All right, so we're only doing 2 slides. We're going to do the outline slide and the slide that comes right after it. That's all we're doing. It's pretty easy, just an intro day. So the outline of what I want to cover in the next like 3 or 4 days in here. I want to talk about the definitions of a polyhedron. That's a 3-dimensional shape. Do some of the different names of those objects. Polyhedra is plural. Okay, so polyhedra versus polyhedron. That's a 3-dimensional object. We're going to go through the definition. Second, we're going to talk about what a face is on a polyhedra, right? A single object, right, or multiple objects. Faces are like the walls. We'll talk about the definition. We'll talk about edges again. We'll talk about vertices again, because those are words that don't go away. Then, once we're through there, then we're going to start talking about specific types of polyhedron. So like, for instance, prisms, or pyramids, or, it's another one we talk about. We talk about, not the regular ones, but we talk about cones, cylinders, spheres. Those are different types of polyhedron. Now we're getting into curves, like conic sections. So we do deal with a lot of different 3-dimensional shapes and other objects, like circles and stuff. But once we're through the basic names, then we start talking about the most special ones. They're called the regular polyhedra, or Platonic solids. They're super important. We'll talk about those later this week. I don't know what day, maybe Thursday. Tomorrow's more or less kind of intro day for all those different shapes. But we're going to learn formulas though. You know, how to find perimeter, how to find surface area, how to find volume. Those are things we need to learn. Okay. Now today, our only goal today is just to get the word polyhedron and know its definition. That's all I want to know. Just what is it? What does it look like? That's it. One simple slide. Because we're going to take this slowly by slowly this week to make sure everyone knows it. Now, in the middle of this, we're still going to review, you know, triangles, quadrilaterals, pentagons, hexagons, heptagons, all those. Because they're still a part of these. But then we start learning properties about them now. There's going to be a lot. Okay, questions at all about what we're doing? Perfect. Let's jump right in and let's talk about the polyhedron.
I like that transition.
Yeah, it's a good one. Okay, polyhedron, that's singular. Polyhedra is plural. But what a polyhedron is, it's a three-dimensional object, but it's a solid. That's what they call it. It's a solid, it's an object that has all flat surface areas. So there's no curves to it for right now. It's got flat surface areas that are enclose, I should say, a singular region of space. So it's an object that has flat surfaces, not curves yet, that encloses single regions of space. Now, you're thinking single regions, like that's a weird definition. Let me give you an example. Imagine you had that Carmelo candy bar thing. Carmelo candy bar thing is that chocolate bar that has all the caramel in it, you can break off the pieces, right? That thing is not a polyhedron. The reason why is that the object itself, if we were to look at it like it's, this is top down, we look at it from its side profile. The candy bar looks something like this, right? And the idea is that you could snap it off and these would be individual shapes, individual polyhedron, right? Because they're enclosed perfectly by themselves. There's two spaces that are enclosed. I can't have that. There can't be that thing where it's cut off perfectly. What this definition says, it has to be a single space on the inside of it. So like a Twix bar. It's one solid object all the way across. It's not broken up into pieces on the inside, like this thing is, where it's separating objects, where you can break them up clean. Okay? So, probably just made everyone hungry. So, let's talk about the actual objects themselves. So, the flat surfaces are called faces. So you can see it there. That's the flat surface on the object. It could be any wall. This room has faces. It's every wall in this room is a face. Okay? So the walls, the flat surfaces are called faces. You can see it on that picture. So that's like a picture of an ice cube kind of thing. Now, the faces themselves are the shapes of the polygons. So that in this picture, they're all quadrilaterals. They're not squares, they're not rectangles, but they're quads. They're four-sided figures. They can be randomly sized. Okay. The picture also has edges. Edges are the line segments where the faces all meet. So in this room, we do have edges. We have this like beam going up the wall over here. We have this part right here where it meets the window. We have the one back there. We have the one back by the door over there. Like there's seams. It's right where the two walls meet. Okay, those are called edges. They're line segments that meet. Okay, so when you even have it, you can actually see line segments on other objects like this is a pyramid, a square pyramid. But it still has bases, still has vertices. The vertices are the corner dots on objects. Even if they don't have a dot sitting there, you can assume you can put one there for all the corners. That's a vertex or vertice is where the major edges meet, or the faces meet. They intersect. That's called a vertex. Once you have this done today, you're done. You can put your notebook away. That's all I want. Just this is the basic definition I want you to have before we walk in here tomorrow. And we start talking about all the different names of the polyhedrons. Tomorrow, bring your Chromebook. We might try for the first time using a program that I have for PowerPoint, so you can actually see the PowerPoint in front of you instead of like looking up here at the marker board all the time. Now, I will warn you, it will close out all your tabs, the program that I use. So you better save and bookmark your tabs. So, especially if you have homework. I'll warn people before I activate it.
Really done.
Alright, so that's it for today. Pretty easy.
I'm fine. Ninth period, you take 20 minutes of your class.
Bar,